All right, I always like to kind of give you guys a preview of what the chapter has to come. So today is the 22nd. We are starting chapter 2, so it's 2.1. We on 3? Lord help me. Chapter 3. Thank you. We're going to start on chapter 3. I would have figured that out eventually. All right, and I want to kind of go through with you chapter 3. Chapter 3 is still doing equations. We're going to have multi-step equations. So far, we've done one-step and two-step equations, right? Now we're going to have multi-step equations. We're going to have to simplify expressions to kind of get it where it's more than one step, more than two steps to get the variable alone. Those are multi-step equations. And then we're going to get into inequalities. So we're going to have the same thing with equations, but instead of equal signs, we're going to have the greater than sign or the less than sign. That's what this whole chapter is in general about, multi-step equations and then into inequalities. All right? So let's just start with this first one. All right? 3.1, these are our two-step equations. So we are going to solve two-step equations. So that's what we need to start with first. In the last chapter, we dealt with one-step equations. Go ahead. Thank you for waiting. Be nice to it. It's brand new. Okay, so let's review where we've been. When we have one-step equations, all right, what that means is that we only need one step or one operation to get the variable alone. That's what we've been doing. All right, an example of that, I'll give you two of them. So one might be negative 3x is equal to 12. All right, well, how do I solve this? What am I going to do to solve this problem? Colin? Excellent. And then what is 12 divided by negative 3, Colin?
It would be
negative 4. So here we just needed the one step of division to get my variable alone. Another example might be a plus a negative 6 is equal to a negative 15. This is also a one-step equation. How do I solve this? Cameron? I'm going to add 6 to both sides because a positive 6 and negative 6 equals 0. All right, so I have a is equal to a negative 9. These are one-step equations. There's one operation to get the variable alone. All right, when we talk about two-step equations, what do you suppose that means? If a one-step equation is we need one step or operation to get the variable alone, what do you think a two-step equation is? Ada? I like how you're thinking, but that's not it. That's going to be a multi-step equation, so keep that in your head, my young friend. Valentina? Yes, I'm going to have two steps or operations to get the variable alone. So here I have two steps or operations to get the variable alone. All right, I'm going to go ahead and just do a problem for you with a detailed steps off to the side, kind of show you what our goals are. Keep your goals in mind of what we're looking to do to solve equations. Because when we get to multi-step equations, if you keep the goals in mind of what you're trying to do, obviously the ultimate goal of getting the variable alone, but the goals in the meantime, those intermediate goals, if you keep those in mind, you can solve any problem. Okay? So let's take a look at an example. I'm going to do my example to my right, or I'm sorry, to the left, and some steps to the right. I like to do that, as you guys know, on the first one, so you guys have some explanation there. So if I have 3x plus 7 is equal to negative 5, and I want to solve. All right, my first step is get the variable term alone, not just the variable term. These are like unwrapping a gift, or order of operations in reverse. That's kind of what I want you guys thinking about, is order of operations in reverse. You know, if you're wrapping a gift, don't you kind of like, you cut the paper, you fold the paper on, you take some tape, put tape on it, right? And then you get the ribbon and you tie the ribbon onto it. If you're unwrapping a gift and your mom's like, wow, that's really great paper. Save that paper. And you're like, oh my gosh, it's wrapping paper. You're like, okay, I'll save the paper. So then you untie the bow. You kind of go through and you try to really carefully undo the tape and you unwrap it. All right, this is kind of the same thing. Order of operations is like you guys wrapping a gift. First, you've got to cut the paper. You've got to put fold the paper on there, tape it. Then you do the bow. Solving equations is like going in the reverse direction. You got to undo the bow and then take the tape off and open the paper up. I want you guys thinking of it that way. So what I want you guys to think is, I want you to think order of operations in reverse. That's what I want you guys thinking of. All right, so what is my variable term here? I'm going to rewrite my equation because I don't want to touch it. What is my variable term here? Remember, the first step is get the variable term alone. What the heck am I talking about? What am I talking about? Amanda? The 3x. There is our variable term. I want to get that alone. Okay, mathematically, how do I get that alone? This says 3x plus a positive 7 equals a negative 5. How do I get that 3x alone? Cameron? No, I'm not dividing by 3. I need to get the 3x alone. I do not want you right now thinking I need to get my x alone. My next line needs to read 3x equals some number. I want to get the 3x alone here, not the x. Patrick? Why am I doing 7 plus negative 5? These two are on the different sides of the equal sign. So let me ask you guys something. If I gave you a problem that looks like this, if I gave you x plus 7 is equal to negative 5, what are you going to do to solve this? Addie? Yes. I'm going to add a negative 7 to both sides. How many of you guys agree with that? Why? Why is she correct in adding a negative 7 to both sides? Matthew? Exactly. I need to make this a 0. And since this is a positive 7, the only way to make it a 0 is add its opposite to it, or add a negative 7 to it. Because my goal was to get the variable term alone. Just because that is also the variable, it's still the same goal. Put your feet down, please, AJ. So someone tell me, on our problem here, I need to get the variable term alone. What am I going to do to get the variable term alone? Sarah? Yes. I'm going to add a negative 7 to 7, which means I'm adding a negative 7 to the negative 5 as well. Remember, our goal is to get the variable term alone. I'm not getting the variable alone right now. I first need to get the 3x alone. So I have 3x is equal to, well, this is a negative 5 plus a negative 7, which is a negative 12. So now comes my second step. Now we want to get the variable alone. So that is going to be in this step. Now what do I do, Cameron, to get the variable alone? Now I'm going to divide by 3 on both sides. So I end up with x is equal to negative 4. Questions? Okay, let me give you another one that I want you to practice on. Please, oh, by the way, how can I check my solution to make sure I got the right solution? How can I check it? Alex? Put your hands down. Yeah, can I just take this negative 4 and put it in for my x? Yeah, absolutely. What that means when I check my solution means I want you to substitute x equals negative 4, that negative 4 in for x in the equation, and see if it makes the equation true. So in your homework, they may say to you, check your solution. I'm going to do exactly what Alex said. I'm going to take that 3 times negative 4 plus 7. I'm looking to see, does that equal a negative 5? If you notice, I put a little question mark over the top. When you are on a test or you are in a quiz, even if they don't say check your answer, don't you think it's a good idea to check it just to be safe? Okay, so even if it's mental math, throw it in. All right, so this is negative 12 plus 7 equals negative 5. Negative 5 equals negative 5. That negative 4 was my solution. So in the homework, if they say check your solution, that's what they're meaning. Are you guys cool with that? Okay, let's move on. Let me give you another one to do. So I want you to solve. We're just looking at the skills today, and then we'll dive into story problems tomorrow. All right, I have 2 equals 6h plus 20. All of you solve that, please, and check your answer. Check solution. When you're done, check with someone sitting by you, see if you guys got the same thing. What's up, bud? I'm sorry? No calculators. Thank you for asking. No calculators. Okay. What am I going to do to solve this? What am I going to do to solve this? It's my first step. Sophia? Excellent. Yep. So what do I get after that? Excellent. Now what? Excellent. And yep. Or h equals negative 3. I don't hear the order. Yep, I don't hear the order. All right. What would I do to check this? So somebody walk through the checking process. Eddie? Excellent. Right? We just solve it, right? 2 is equal to a negative 18 plus 20. 2 equals 2. That is correct. So that is our solution. Again, when you're on a test or a quiz or even your homework, just do that mentally. Put it in real quick. That's easy mental for you guys. Okay, let's look at another one. This one's going to look a little different. But the idea, remember, you have to think about what your goals are. No matter what the equation looks like, think about the goals in mind. So I have x over 2 minus 3 equals 11. All right, let me put a little asterisk here. Use adding the opposite first. It stops a lot of issues. Use adding the opposite on the subtraction. I highly recommend that. So I'm going to go ahead and do that in my pen. Remember, our goal is the same, even though this looks a little different. What's our first step? What's the goal of our first step here? What's the goal of our first step? Sarah? Excellent. I want to get that variable term alone, get rid of that negative 3. Sarah, what am I going to do to get rid of that negative 3? Sweet. So I get x divided by 2 is equal to 14. Now what's the goal of this step? Now what's the goal of this step? Valentina? Why? I totally agree with you. Why? Exactly. I want to get that x alone. I need to cancel out the 2's. This says x divided by 2. I need to get rid of the 2 in the denominator. To do that, I can multiply by 2 over 1. I'm going to multiply both sides by 2. When I do that, I'm just going to do the quick check that I did that right. My 2's divide out. I use divide out common factors, DOCF. Do you guys remember me saying that before? So DOCF, divide out common factors, yep. So I get my x is equal to, well, 14 times 2 is 28. You guys cool with that? All right, let me give you another one to look at, and then I'm going to give you a bunch of them to practice on. Are you guys cool? Okay, so let's do another one. I'm trying to give you some that look different because I want you to keep all the goals in mind. Yeah. This one here? Yep. Yep. No, I've dropped that stuff for you guys. And on your test, ladies, you don't need to do that. You don't need to show x plus 0. I talked about that with the rest of the class. You didn't need to show that stuff. Just so you know. So nope, we can leave that out. All right, so let's do another one. Let's do 7. Stop talking, please, gentlemen. I have 7 minus 4y is equal to 19. What should be the first thing that I do here? After listening to and taking notes on the other problems, what's the first thing that I should do here? Brendan? Add the opposite. Excellent. This one looks a little different than the other ones than we've had, because we have 7 plus a negative 4y. The goal, remember, is still the same. I want to get that variable term alone. What am I going to do here to get the variable term alone? Ada, what am I going to do? You're more than welcome to. You could switch the order of these using the commutative property because it's addition. If you want to do that, you are more than welcome to. You do not have to. But if you prefer to see that variable term come first, by all means, go ahead and do that. And that might clear things up for you, right? That might be like, oh, I know what to do now. All right, but in either case, what am I going to do to get my negative 4y alone? Patrick? Excellent. I'm going to add a negative 7 to both sides. I'm just going to do them on both of them in case you want, if you changed it or you didn't change it. And I'm going to do that to both sides on each. Remember, I want you adding a negative, not subtracting. It just stops a lot of mistakes. All right, so I end up with negative 4y is equal to 19 plus a negative 7 gives me 8. Did I do that right? No. 12. 12. All right, and that's true for both of these. That's where we are for both of them. Now what? Now what? Amanda? Excellent, that's exactly right. I'm going to divide both of those by negative 12 because this is negative 4 times y. So remember, I get rid of all addition or subtraction first, then I get rid of your multiplication and division. Order of operations in reverse. So I end up with my negative 4's divide out, and I end up with y equals negative 3. Are you guys cool with these? Okay, so let me give you a bunch that I want you to practice, okay? So let me write them down. I'm just going to write them all down here. Just do one at a time. All right, you don't have to write them all down at once. I'm going to. Just do them one at a time. So those are the 4 that I want you guys to do, just one at a time. Please go back and forth with your notes as you need to. Go over the ones that we've done. All right, so just be real diligent about using the notes that we've had on the other ones that we've done to help you. Is someone wrong with these things with you? No, it's me. As you're doing your notes in color or in pencil, anything you want to highlight in color, you're always welcome to. So if you'd like to see that adding the opposite of a different color, you're more than welcome to use that, right? So you can do any of that to highlight your notes to help you. Troubles, help each other. Talk it through with each other. Remember, you can, when you're done with all 4, you can go back real quick and check your work real quick. Just do a mental math on each to make sure you got them right. On that third one, you want to know what positive n equals. Keep that in mind. Think about what that coefficient is if you have a negative n. What is that coefficient if you have a negative n? Remember, when you're done, check with someone sitting by you, see if you guys got the same answers. You can talk. I don't mind you guys talking. You don't need to whisper. You can talk. I'm happy to have you guys talking. That last one has a little bit of a trick to it. That one can be a little confusing. We're going to talk about that negative sign when you do adding the opposite on that last one. Who's still working? Okay, I'll give you another minute or 2 to finish up. All right, so let's take a look at that first one. Even if you're not done, we can catch up to it. So somebody completely solve that first one for me. Tell me what to do. Whose voice have I not heard? I'm totally going to start calling people that I haven't heard their voice. Molly, do this for me. So we're looking at number 1. Excellent. So then what do I have? Excellent. Now what? Excellent. And what do you get for your x? Sweet. How many of you guys got that? Awesome. Who'd like to do number 2 for me? Danny, do 2 for me. Yes? Excellent. No. Positive 2. Excellent. Add a positive 2 to my negative 2 and a positive 2 to my 6. And what do I get after I do that? Excellent. Excuse me? I'm not just doing 6 times 8. Don't I have to multiply both sides by 6? Why am I multiplying 6 by 8? Put your hand down. Why am I multiplying 6 by... Put your hand down. Why am I multiplying 6 by 8? I don't disagree with you, but why am I multiplying 6 by 8? So I need to multiply this by 6. Isn't the reason I'm doing that because I have to do this first? So isn't the reason I'm saying 8 times 6, isn't the reason I'm multiplying by 6 is because on this side I have to multiply by 6 to get rid of that 6? Does that make sense to you? So that's how I need you to think about it. That I have to multiply C over 6, C divided by 6 by 6, so these cancel each other out. Whatever I do to one side, I do the same thing to the other. Does that make sense? I just want to make sure you understand that is why. I need you to know why you're doing that, okay? So you're right. I have C is equal to 48. And if I did a really quick check to this, 48, put it in there. 48 divided by 6 is 8. 8 plus a negative 2 is 6. I know I got that right. All right, who wants to do the next one for me? AJ, do this one, please. Awesome. Oh my gosh, why did you think to do that? How many of you guys thought to do negative 1n? Awesome. I love that, because if you all of a sudden get this when you're done, I'm sure some of you are like, I don't know what to do with that. How many of you guys agree that you'd be like, I'm not sure what to do with that? But if you recognize, AJ, that's a great idea. You recognize that negative n means I have a negative 1 times n, then you might be like, oh, I know exactly what to do with that. All right, so go ahead, bud. Thank you. Excellent. 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 That's perfect. Nice work. So that's one thing I would say to you. If you did not, when you did adding the opposite here, if you just left it as a negative n, that's fine, but you have to recognize that a negative n is the same thing as a negative 1 times n. All right, and that might be a good idea to switch that. All right, Ada, do the last one for me. Okay, so here's my question for you. You're absolutely right. Where did you put the negative? How many of you guys put the negative on the x? Awesome. Could I have put the negative on the 7? What do you guys think? Could I put the negative on a 7? Sophia? Yeah. It's a negative fraction. Either the numerator is negative or the denominator is negative. So my question for you is, there's no right answer to this. If you want to put that negative on the x, then you're going to get left with something like this, where I have negative x equals something. If you put the negative on the 7, then when I'm done, I just have a positive x. It doesn't matter which one you do, as long as you recognize in the end you need a positive x. Does that make sense to you? All right, so let's put the negative on the x. All right, so if I do that, and I'll do the other way as well, just so you can see it. Ada, what do I do now, sweetheart? Finish up. Excellent. Excellent. Okay, you did 7 over negative 1. What I would like for you to do is just multiply by this reciprocal. So I would multiply by 7. You're not wrong, but I feel like that can get confusing as to why you did that. I would keep that one separate. I'm not going to mark you down, but I think that can get confusing if you do that. All right, so I would multiply both sides by 7, or 7 over 1. Negative x equals 98, and then divide each side by negative 1. Okay? Excellent. I don't disagree with you. Now, if you had done this, if you had put a 1 here, then that is, you can see that better. You know what I mean? You can see why you did that better. If you did that, that's fine with me. I don't mind, but understand why you're doing that. All right? I could have also put the negative on the 7. So I could have done negative 5 is equal to negative 19 plus x over negative 7. That's another way that I could do it, is put the negative there. So I just always keep a positive x, a positive coefficient. But I would do the same thing. I would still add a 19 to both sides. But here, I'm multiplying by a negative 7 over 1, or a negative 7. So I'm going to divide both sides by, I'm going to divide out common factors here, and I end up with exactly the same answer. Just a little tip. That negative can go on the numerator, or the negative can go on the denominator. It doesn't matter. What do you guys think of these? You guys cool with these? Okay, so this is what you're doing tonight, is you're doing these skills tonight. We're going to talk about story problems and what a two-step equation looks like in a story problem tomorrow. Okay? You guys cool? All right, for once we are not late. I know, right?